Hey class, it's Professor Fowler, and this is a brief video concerning weight and balance. Pilots are required to perform a weight and balance on their aircraft before every flight. While it's not specifically mentioned in the regulations, it is part of knowing whether you're meeting the aircraft's performance limitations. And so you could say that it is required by the regulations, but even if it weren't required by the regulations, it's always a good idea to know that you're within the weight and balance limitations of the aircraft. Uh, there are a couple of things that can happen if the aircraft isn't within weight and balance. You can actually have a higher takeoff speed, longer takeoff run, a reduced rate of climb as a result of being too heavy, shorter range, reduced cruising speed. It can reduce maneuverability of the aircraft, result in having a higher stall speed, higher approach and landing speed, longer landing roll. And so there are several problems that could result in not complying with the weight and balance limitations of an aircraft. A couple of terms that you should know before we move on. Gross weight includes the weight of the airplane and all installed components, plus the pilot and passengers, any baggage, and fuel and oil. Empty weight includes the weight of the airplane and all installed components, but it does not include fuel or fluids or the weight of passengers and luggage. A couple of definitions. Weight is the actual weight of all the items. Empty weight is the aircraft's weight plus all installed items. Arm is the horizontal distance from the datum to the center of gravity. And the datum is an imaginary line that the engineers designate when they first design an aircraft to measure the distance back to each item in the aircraft. The moment is a product of the arm, or the distance from the datum, times the weight of the object. And the center of gravity is the point on the aircraft at which it is perfectly balanced. So imagine for a moment a child's seesaw. Excuse me. And imagine that there are equal weights on both sides of the seesaw. The balancing point on the seesaw, which is otherwise known as the fulcrum, if both of the items are an equal distance and an equal distance from the fulcrum and an equal weight, that seesaw should balance perfectly. Now let's imagine that we move one of the weights a little further away from the fulcrum. What would happen? Well, because of the longer distance from the weight to the fulcrum, that side of the seesaw would actually overcome the weight on the other side of the seesaw, even though the weights are equal because of the longer arm. Longer arm means more force. The CG on an aircraft, the center of gravity on an aircraft, and the weight and balance works under the same concept. The distance from the datum back to each item in the aircraft, otherwise known as the arm, you can compare to the distance on a child's seesaw from the fulcrum to the item that's being weighed. A couple of equations that are important to remember when you're doing a weight and balance. Weight times arm equals moment. Weight times arm, which is the distance from the datum back to the item that you're weighing, equals moment. Another equation to remember is the equation for the center of gravity. Once you have all the weights, arms, and moments calculated, then you take the total moment divided by the total weight, and that will give you the center of gravity. You can take that information now to the Pilot's Operating Handbook Weight and Balance section. Some weight and balance sections will have loading graphs where you can actually determine the moment for each item based on the graph. All POH weight and balance sections have what's called a weight and balance envelope. And what you do is you take the weight, the gross weight of the aircraft, and the center of gravity that you calculated, and you plot that on the weight and balance envelope. And if it falls within the envelope, the aircraft is within the weight and balance limits. So a couple of terms to remember when you're doing weight and balance. Again, remember, while it's not specifically stated in the regulations, it is part of the aircraft's operating limitations, so you should have a weight and balance in the aircraft for every flight. You determine the moment for each item in the aircraft by multiplying the distance from the datum, which is known as the arm, times the weight. Arm times weight equals moment. Again, the reference datum is an imaginary line, and the engineers that design the aircraft designate that imaginary line so that you can measure from there to the item to get the arm. The datum on every aircraft is different. Some datums are out in front of the aircraft, some datums are in front of the firewall, but they all serve the same purpose. Later on, I'll post a video actually performing a weight and balance, and I'll also demonstrate how to do a weight shift. Let's say, for example, you do your weight and balance, you find out that you're within the maximum gross weight limitations of the airplane, so it doesn't weigh too much, but it's not within the weight and balance envelope, so it's out of balance. There is a formula that you can use called the weight shift formula that can help you move a weight in the aircraft to solve that problem. That formula is weight moved over total weight of the aircraft equals the distance the CG moves over the difference in arms. And usually, what you'll have is the weight that you want to move, the total weight of the airplane, and the difference in the arms between the two items. And then you can, if you have those three items, you can solve for the distance that the CG moves so that you can determine whether it will fall within the center of gravity limits. If you have any questions, you can send me an email. I will also post a PowerPoint presentation on weight and balance that you can review. Thank you.